Hi everyone. Today we will be completing our notes on classifying polynomials or discussing some important vocabulary when talking about polynomials. We're going to go ahead and begin with the Inspire activity titled Introduction to Polynomials. If you're following along with me in class, then you can go ahead and follow along with the program that I've distributed to you. Or if you're following along with the video, then just follow along as I go through this. So let's take a look at this program, Introduction to Polynomials. Let's go ahead and flip to page 1, 2. A monomial, that's how it's pronounced, monomial, is an algebraic expression consisting of only one term and only whole number exponents. So a monomial has exactly one term and has whole number exponents. So as a reminder, whole numbers, those are counting numbers, so 1, 2, 3, 4, 5, and so on. And then also 0. This does not include negative numbers, does not include fractions, irrational numbers, anything like that. So let's take a look. Is 12 a monomial? On the following page? Oh, let's take a look at some examples first. So examples, -5, a, 1/3 x, xy to the third. Notice all of these are just a single term. There's no addition or subtraction. And all of these exponents are whole numbers. They're either 0 or counting numbers, 1, 2, 3, 4, 5. The number in front, the coefficient, can be a fraction. As long as the exponent is a whole number and there's only one term, we have a monomial. These are not monomials because they have two terms, each of these. They're separated by addition or subtraction. Okay, so now let's consider 12. Is 12 a monomial? What do you think? The answer, yes, this is a monomial. The exponent this would be like an x to the 0 term, so there is no exponent here. And then this has just a single term. Okay. What about 4x plus y? What do you think? Is this a monomial? The answer, yes. I'm sorry, no. No, this is not a monomial. This is a binomial, which we'll learn soon. This has two terms. It's separated by addition and subtraction. All right, next up. X squared y to the -3. Is this a monomial? While this is only one term, it has negative exponents, which contradicts that monomials have only whole number exponents. This is not a monomial. How about this one? What about ABC to the 8th all over 4? Is that a monomial? The answer? Yes, it is. There's only one term, and all of the exponents are whole numbers. We could rewrite this as pull that coefficient out front and write this as 1/4 ABC to the 8th. So remember, those coefficients can be fractions, but not the exponents. Next page, a polynomial. Notice it's the same word, but with a different prefix. A polynomial has many terms. It's like a monomial or a sum of monomials. So it can be one or more terms. So here we have x to the third, x squared plus y squared, z squared minus z plus 9. Notice it's a sum of monomials, so it can have many terms. And again, still, it can only have whole number exponents. So no negative exponents, 0 or positive counting number exponents only. Is this a polynomial, x to the -2 plus y cubed? The answer, no, this is not a polynomial. This has a negative exponent. Oh, we got to fill in our blanks. It's a monomial. A polynomial is a monomial or a sum of monomials. A polynomial cannot have negative exponents. There we go. What about 3x cubed minus 2x squared? Let's see. Is this a polynomial? The answer, yes, it is. Only whole number exponents, and it's monomials, separated by addition and subtraction. What about 6x to the 5th? Is that a polynomial? The answer, yes, it is. This would be a monomial. Okay. Let's take a look at the next page and see what do we notice about terms? What can we say about terms? So The number of terms is how many monomials are added or subtracted. So look at how many things we are adding or subtracting. This has two terms, where the terms are 2x squared and 3y. The next polynomial has three terms, which has terms 2x squared, negative 3y, and positive 5. And the last polynomial has four terms, which are 2x squared, positive 3y, negative 5x, and negative 3. So the terms are parts of the polynomial expression that are added or subtracted. How many terms are in the expression 7x plus 8y? There are two terms. The terms in this expression are 7x and 8y. These are the terms that are separated by addition and subtraction. Okay, next page. The number of terms helps us classify polynomials. If it has one term, we call it a monomial, mono being the Latin prefix for one. If it has two terms, then we call this a binomial, bi the Latin prefix for two. And if it has three terms, we call this a trinomial, tri being the Latin prefix for three. If there's more than three terms, so four or more, then we just call it a polynomial, poly being the Latin prefix for many, just has many terms. Okay, so a binomial has exactly two terms, and a trinomial has exactly three terms. So let's take a look on the following pages and classify these polynomials by the number of terms. 3x squared plus x plus 3, how many terms does it have if it's a polynomial? This is a polynomial, and it has three terms. We call this a trinomial. Okay. On the following page, 3x to the negative 2 plus x. This is not a polynomial. This has negative exponents. So on 114, not a polynomial. On page 115, 5abc cubed. This is a polynomial. There is no addition or subtraction, so there's only a single term. This is a monomial. 116, let's check it out. Y to the fifth plus y. We have two terms separated by addition, so this is a binomial. Okay. 117. 5x to the fourth plus 3x cubed plus x plus 3. This is a polynomial. We have whole number exponents, and there are four terms. So four or more, remember, we just call a polynomial. Okay. And finally, on page 118, this is a polynomial, particularly a monomial. This has one single term. Okay. We also classify polynomials by the degree. So we classify by number of terms and the degree. The degree of a polynomial with a single variable is the largest exponent on the variable, or I like to say the greatest exponent. So greatest in quantity. So if we look at the example, if we have 8x squared plus 3x to the fourth minus 5x minus 3, the degree of this polynomial is the greatest exponent, which in this case is 4. So the degree of this polynomial is 4. Let's get some practice. Find the degree of the polynomial 5x cubed. Well, the largest exponent is the only exponent. The degree here is 3. For page 2-3. Find the degree of this polynomial. Well, there are two exponents. We take the greatest of them. The exponent here is 3. On the following page, this one here, 4x. Well, there's no exponent written, but because we have a variable, we can assume that that exponent is 1. So the degree of this monomial, 4x, is 1. Next page, negative 13. Well, there are no x's, and there are no exponents, So the degree of this polynomial is 0. So notice the difference between the previous one and this one. The previous one had an x, which is raised to the power 1, and this one doesn't have an x at all. So the degree is 0. And last, we've got a polynomial here. The greatest exponent is 5. So the degree of that polynomial is 5. All right. In summary, a monomial is a polynomial expression that has exactly one term. So which of these are monomials? Remember, separated by addition or subtraction, we only want terms that do not have any addition or subtraction. So 12 is a monomial. 4x plus y has addition. This is not a monomial. X squared, y to the negative 3, is not a polynomial at all, so that's not a monomial. 2n is a monomial, whole number exponents, one term. 5z also is whole number exponents, one term. And finally, abc to the 8th all over 4 is also a monomial. That was in the earlier in these notes. A polynomial has one or more terms and only positive exponents, or I should say whole number exponents. Okay, only whole number exponents. The terms of a polynomial are added or subtracted. The degree of the polynomial is the greatest exponent. So let's find the degree. 5x plus 8, well, the exponent here is 1, and that's our greatest exponent. The exponent over here, well, there's nothing written over here, but I know that the greatest exponent is 2, so this has degree 2. Finally, let's go ahead and fill in that imaginary 1. Our greatest exponent in this expression is 4. So this has degree 4. So again, in summary, we define or we classify polynomials by the degree and by the number of terms. So I'll summarize everything here. If the degree is 0, we call that a constant. There are no variables, so it remains constant. If the degree is 1, similar to this first example here, we have a linear polynomial. If the degree is 2, we have a quadratic, which is our next unit. If the degree is 3, we have a cubic. If the degree is 4, we have a quartic. If the degree is 5, we have a quintic. And if the degree is greater than or equal to 6, then it's just named by the degree. So what I mean by that, I'll just put in parentheses, nth degree. So whatever the highest exponent is, whatever n is, that is the degree of the polynomial. So if my highest exponent was 6, this would be called a 6th degree polynomial. If my highest exponent was 1 million, this would be a 1 millionth degree polynomial, right? We also classify polynomials by number of terms. If it has one term, we know this is a monomial. If it has 2 terms, it's a binomial. And if it has 3 terms, it's a trinomial. And if it has greater than or equal to 4 terms, we just call it a polynomial. Okay? So if I were to classify each of these polynomial expressions, on the left-hand side, 5x plus 8, well, the degree is 1 and it has 2 terms. This would be a linear binomial. 2a squared plus 9a has 2 terms and the degree is 2. This is a quadratic binomial. And finally, 7 minus y to the 4th plus 3y has degree 4, and it has 3 terms, so this would be classified as a quartic trinomial. All right. So we're going to get a whole lot of practice on classifying polynomials. We'll see you tomorrow in class. Have a great day, everybody. Goodbye.